Hello and welcome to our STEAM projects based on the Raspberry Pi Pico and MicroPython. These lessons are designed for the somewhat experienced STEAM teacher. We call this second level the SHERPA level. In our project number 3, we are going to program a light dependent resistor to switch on and off an LED depending on the ambient light. My name is Peter, I am the founder of Educomondo and a certified STEM instructor and course developer. The goal of today is first to introduce a new component, the light dependent resistor. Secondly, we will integrate this LDR in a project to automatically switch on an LED when it gets darker. We will also learn how to program the LDR in MicroPython, and probably the most important, we will make sure that your class works as a team. Let's start by looking at the LDR under the microscope. This component is a resistor of which the ohm value changes according to the light level that falls on the lens. You can clearly see the spiral of the resistor. Now, because it is a resistor, we can measure its ohm value with a multimeter. When we shine some light on it, you will see the value go up when darker and go down when lighter. Like many other sensors, we will be measuring an analog signal and transform it into a digital format. For our project, we will need the following components: the large breadboard with the Pico installed and the pinout reference card, the LDR, a red LED. We will also need a resistor of 160 ohm and one of 10,000 ohm. We will set our box of preformed wires and a bundle of jumper cables. Okay, now that we have all of that, we first install the LDR on the breadboard. One leg is connected via the 10,000 ohm to the ground, and the other is to the pin ADC0 or pin number 26. There is no polarity, so both legs are of equal length and you cannot install it wrongly. The red LED is pushed into the breadboard and connect the short leg or the cathode to the negative rail. The long positive leg or anode is connected via the resistor to GPIO2. Checking our reference card, this is the 4th pin. Open Thonny and create a new file. The first step is to import MicroPython libraries or modules. As we have seen in our previous lesson, you can either import complete modules or select certain classes. In this exercise, we will import what we need for the program. So, from machine, import ADC and pin. You've probably recognized that the machine library is the most used as it contains the typical commands to address the microcontroller's functions. In this case, we will use the analog to digital converter and the pin class. Because we will also need some delays, we are typing from time import sleep. This is the Python's way of defining a delay. Next, we will create objects from modules. So the pin where we put our LDR, so LDR pin equals ADC and in between brackets 26. And then our LED pin, which is pin number 2, and it is a output pin. And the way to type this is pin.out. Now we write a program to go on forever while it is true, and when it is true, it is true. So while true, this creates an infinite loop. The LDR underscore value equals, again, reading from the LDR pin, or LDR pin dot read underscore U16, open and close the brackets. So LDR value is what we read from the object LDR pin, and the U16 tells us that we will expect a 16-bit number or a number between 0 and 65,535, or 2 to the 16th power. To check the reading, we monitor this in the REPL or the shell space of Thonny. And it's a simple print command, so print and in between brackets the value LDR underscore value. And here we introduce a delay of 1 second, so sleep and in between brackets 1. Now we continue with an if-else statement. That statement will check whether the LDR underscore value reading will surpass a certain value. When a certain value is reached, we can attach an action to it. So if, in between brackets, the LDR value is larger than or equal to 5000, the LED pin value is set to 1, and we keep it on for 5 seconds. If not, so else, the LED pin value is set to 0. Now you may have to experiment a little bit with the 5000 because not all light dependent resistors will have the same threshold. In our case, it happens to be a 5000. So let's upload the code and check whether everything is working properly. So when there is daylight, the LED will not switch on, but the moment that we cover the LDR with our hand, you will see the value that we will read from the sensor is going up quickly. And when it reaches the threshold value that we have set at 5000, the LED switches on, and it will do so for at least 5 seconds, even if in the meantime the LDR value drops below the threshold value. If this all works perfectly with your class, a big congratulations. If not, no panic. Let's do some logical fault finding. Were there any error messages in the REPL of Thonny? Did you select the right Raspberry and comms? Did you connect the components to the right GPIOs? Has the LED been mounted correctly, taking the polarity into account? Are there any loose wires or legs? Or maybe you're just unlucky and one of the components is broken. Well, that's it for our third lesson. I hope you and your class enjoyed it. For our fourth lesson, we are going to use a sound sensor to control the switching on and off of a DC motor. Looking forward to welcome you again, and bye bye for now.